So yun, good afternoon everyone, and welcome again to 2s2122. So now we are on week 4 ng ating activities, pero dahil yung deadline for yung may deadline bukas, yung week 3, I'm guessing more or less most people nasa week 3 pa rin yung ginagawa. And siguro yon to siguro help yung mga naghahabol and to maybe uh, uh, to fortify or to make sure na nakuha niyo yung ginawa for week 3. Let's just have a little recap ng mga ginawa. And most of the things discussed sa week 3 din naman is gagawin sa week 4. So, ayan. So for week 3 is our week on recursion analysis. So yung sa week 2 is yung time complexity analysis ng mga generic na functions, well, yung mga iterative na functions, yung mga may loops. And so yun, lumalaki yung ating runtime or complexity pag dumadami yung mga loops natin na kukon ng isa't isa. So for week 3, ang focus ay another way of repeating yung ating mga instructions in recursion. And then, ayun, so recursion, medyo mas mahirap siyang tignan, or I guess from the looks of it, hindi siya ganun kadaling i-analyze. So let's go to our main material. Meron tayong factorial na function like this one. It's calling itself. So paano natin kukunin yung time complexity ng ganitong mga functions? So, ayun, since a recursive function is a function defined using itself, ang ating recursive na time complexity or running time is defined using itself then. So effectively, yung running time ni t of n or si factorial of n equal siya sa running time ni factorial of n minus 1 plus some constant time to execute yung commands. So, ayun, kita naman yung nasa screen ko, di ba? So, I guess wala pa namang nagre-reklamo. Baka kanina pa ako nagmo-monologue dito. Wala kayo dito. Okay, so from this, so this is the running time. So, paano natin makuha yung time complexity? So, kailangan natin ma-isolate yung t of n to one side. So, kailangan mawala yung recursive na definition niya over here. And yun din pala, ang tinatawag natin dito is yung recurrence relation. So, paano nagre-relate yung recursive call doon sa running time ng ating function. So, ngayon medyo simple pa. So, factorial of n is just yung factorial of n minus 1. And yung running time ni factorial of n is running time ni factorial of n minus 1 plus some constant. And since meron tayong base case, di ba? So, pag yung ating n, umabot siya sa 1, it's just a constant as well. So, para tumigil naman siya. Baka magtuloy-tuloy. Kasi tuloy-tuloy ito, hindi siya titigil. So, paano natin nga makukuha yung time complexity dito? So, there are two methods. The first method is yung substitution method, which requires a bit of experience and intuition. So, ang ginagawa niya lang is ini-expand natin si t of n minus 1. So if nadaanan niyo na yung videos ko last week, it should be clear na itong t of n minus 1, in-expand siya, naging t of n minus 2 plus c. And eventually, si t of n, while being equal to t of n minus 1 plus c, is also equal to t of n minus 2 plus 2c. And eventually, pwede mo po itong i-break down or expand further and makuha mo pag gusto kong i-equate si t of n kay n minus 4, I get plus 4c dun sa labas. So, pwede kong i-substitute itong 4, itong dalawang 4, para sila nag-occur eh. So, kahit anong i-minus ko sa n dito, siya rin yung i-multiply ko kay 5c. So, replace ko lang siya with k. So, when we have k over here, t of n minus k plus kc1, si t of n. So, whichever k na piliin ko, it will always be true. So, ayun. So sa algorithm correctness natin actually nako-cover kung paano mapo-prove to. But for now, based on our observations, mukha naman totoo. So I guess we can stick to that. So parang tiwala na tama tayo na ito nga yung form niya. So after doing that, we can find for a value of k such that yung nasa loob ng ating recursive call maging t of 1. Kasi di ba, si t of 1, defined siya as C2. So ito yung ating way para matanggal yung ating recursive call. So ayun. So ayun nga. So going from this one, we said k is equal to n minus 1. And since k is equal to n minus 1, so si k naging n minus 1 over here. And then si k over here is naging n minus 1 dito. So itong first term natin, t of n minus 1, eventually becomes just t of 1. And then ito is, and then recall si t of 1, define na siya ng ating recurrence relation as C2. So going back, t of 1, mag-simplify siya to C2. And then we have our C1 term over here. And then when we simplify this, so si constant nagiging 1 pag nag-big O. 1 and 1. So we're left with n. So ang ating time complexity is O of n. And pwede nyo rin naman siyang i-verify. For example, if I have the factorial of 10, ilang beses nagko-call yung function. So factorial of n calls factorial of 9, and then 8, and then 7, 6, 5, 4, 3, 2, 1. So that's a total of 10 functions. So if yung aking input kay factorial naging 20, it will also be 20 function calls. So, ayun. So number of, so for factorial, kung ano yung number of function calls, yun na yun. Parang pinaka-running time natin. But, ayun, what if we have a more complex na recursive na functions? So for example, meron tayong function dito called binary, which prints all the n-digit binary numbers. So ito is binary 10. So expect here, yung mapiprint ay lahat ng 10-digit na binary numbers. Actually, madami pala yun. Pwede ba itong stop? Go back, go back. Konti lang. Ayun, ang dami. So from 000 na 50 hanggang liitan ko na lang para makita natin sa isang screen. So yan. So we have lahat ng 3-digit na binary numbers. So ang operating principle niya is lahat ng 3-digit na binary numbers ay lahat ng 2-digit na binary numbers na merong additional 0 or 1. So lahat ng n-digit na binary numbers ay lahat ng n-1 digit na binary numbers na appended by 1 or 0. So ganun nagpa-function yung ating, or yung parang technique, or yung pinaka-procedure, I guess, ng ating function. So, relative to our original factorial na function, isang beses lang niya tinawag ang sarili niya. But for binary, it calls itself 2 times. So, once yung isang call is nag-attach ng 0, yung other call is nag-attach ng 1. So when we look at the recurrence relation, it's 2 times yung t of n minus 1 na term plus f of n. So right now, hindi lang muna natin i-consider, hindi pa muna natin i-define, I suppose, ang ating f of n kasi yung pag-join ng strings is actually very varied yung kanyang implementation. So madaming time complexities yung pwedeng consider or magiging possible dyan. And then for the base case, yung pag-print, you can also consider it as g of x for now, if hindi pa tayo sure. ano yung running time ng pag-print or yung time complexity ng pag-print. So, we can also apply itong nauna nating method, but we can also use this other method we call the recursion tree method. So in this method is medyo mas graphical siya. Ganun din, nag-expand tayo. Pero the way we expand it is parang nilalagay natin siya into levels. So, para hindi gumagalaw, kung ko yung mga slides ko. So, recall ito yung recurrent oscillation natin. So, 2 times t of n minus 1 plus f of n. So, yung 2 times t of n minus 1 na to, pwede natin silang expand. So, that is 2 times t of n minus 2 plus f of n minus 1. That was 2 times t of n minus 2 plus f of n minus 1. So, dalawa siya dyan kasi may times 2 tayo dyan. So, since ito, in-expand natin, nandito na siya sa baba, ang matitira na lang dito sa taas is yung f of n. And then, pwede natin ituloy-tuloy lang yan. And makikita natin yung ating recursion tree is basically kung ano yung hindi recursive, si f of n, na lumiliit per level. So, yung sa pinakaunang level is f of n, yung next level, f of n minus 1, next level is f of n minus 2, and so on and so forth. Hanggang umabot siya sa f of 1. Then pag f of 1 naman na siya, is magiging g of x yung kanyang time complexity or ix yung kanyang running time. So in this case, ang gusto kasi natin makuha is binibilang natin lahat ng function calls and yung total na running time per level. So recall si f of n ay running time. So since gumawa tayo ng recursion tree, nakikita natin lahat ng functions na i-call para ma-solve si f of n. So in this way, pwede natin ikunin yung total ng lahat ng to. And to be a bit systematic, kunin natin siya per level. So you see here sa level 0, it's just f of n. And then sa next level, we have f of n minus 1, dalawa. Tapos dito, apat na f of n minus 2. So kaya makikita nyo dito, ayan, so for the first level, f of n lang siya. For level 1, we get 2 times f of n minus 1. The next level is 4 times f of n minus 2. So pwede natin i-deduce through this pattern for any level k. So level 2 yung second level, yung kth level, anything sa gitna, is 2 to the k times f of n minus k. So pwede mo yan i-confirm pag dito sa level 3, si n minus 3 siya. So it's 1, 2, 3, 4, 5, 6, 7, 8 terms or 2 to the 8 terms. So once we get this, can actually form our summation. So it's just 2 to the k. Kahit pala may assumption na tayo, f of n is just c. So 2 to the k times c from k equals 0 to d minus 1, kasi magsisimula tayo at level 0, hanggang d minus 1. Siya yung second to the last level. Si d naman yung last level. And then for the last level, we have 2 to the d times g of x. Then, ayun, it's just a matter of recalling yung ating simplifications for summations. So, 2 to the k times c can be simplified to, actually, hindi ko pala simplify. So, we first get yung ating natawag na depth or yung d or yung ilang levels lahat ng to. So to get that, we use observations na kung wari dito sa last level, sa d of d minus 1, si f of 1 yung ating function, but kailangan true din itong nasa taas. So t of d minus 1 is 2 to the d minus 1 times f of n minus d minus 1. So pag simplify mo to, makikita mo lang, makukuha mo lang na d is equal to n. And pwede mo rin naman siya ma-deduce. So for example, n ka dito, n minus 1, n minus 2, n minus 3, all the way to 1 and then 0. So parang pwede mo naman i-deduce. So si n nababawasan siya by 1 every level. So there should be up to n levels, or I think n plus 1 to kasi meron pang f of 0 or yung g of x. So ayun, once you get yung depth, plug in lang dito sa d over here. And then you'll get na itong expression, so from 0 to n minus 1, so hindi na siya d of 2 to k times c. And pwede siyang mag-simplify to 2 to the n minus 1 times c. And then, since g of x, well, depende na lang kung ano yung time complexity ng g of x, multiply mo siya din sa 2 to the n. And then, yun, eventually, makukuha mo na yung ating time complexity dito is n times 2 to the n. So, ayan. So, medyo mahaba-haba siya. And then we actually have a formative quiz doon sa other time complexities. So, actually, let's look. Tingnan natin. Let's look. So ito, yung ating unang question for the formative exercise or quiz is instead na -1, nagiging over 2 yung nasa loob. So paano natin siya pwedeng solve? Now, may try lang ako dahil meron akong whiteboard sa bahay. I guess, yeah. Kita ba? Kita ba yung camera? Para ma-solve natin siya ng nakikita nyo in real time. Gumagalaw yung ating mga stuff. So, write ko lang yung recurrence relation natin. I hope hindi siya masyadong maliit. So, t of n is equal to t of n minus 2, ay n over 2 plus n. So, we can use yung ating substitution over here. So, para gamitin yung substitution, kailangan makita ko sa screen. Para gamitin natin yung substitution, kailangan natin expand yung ating term. So let's just first get saan ba equal si t of n over 2. So si t of n over 2, parang i-plug in natin si n over 2 dun sa n dito sa taas. So we get t of n over 4 plus n over 2. Now, pag i-plug in natin siya ulit dun sa taas na term, we can get na try natin ibang kulay. So gawin natin para ma-iwalay niya si t of n at si t of n. So si t of n equal siya kay t of n over 4 plus n over 2 and yung plus n. So itong buong term is ito. Sinubstitute lang natin siya. Then eventually, not sure if kailangan ko explain further, you can say na pag yung next pag-expand dito sa gitna, t to the t of n over 8, we get over here, so 1/4 plus 1/2 plus 1 times n. So, ayun. So basically, si n nagkaka plus 1 plus 2 ay plus 1 plus 1/2 plus 1/4. And then yung sa next iteration naman or sa next expansion is 1/8. So pwede mo itong i-generalize natin expression. Kasya po ba sa baba? So we can generalize it as t of n times t of n. Tapos since nag-start tayo with 1/2 and then 1/4 and then 1/8, we can use yung ating powers of 2, 2 to the k. And then yung ating ina-add kay n or yung coefficient ni n is parang baliktad ako. Yung pinakamaliit na term natin is times 2 nung nasa loob ni t of n na term. So 1 over 2 to the k minus 1 plus yung dot plus hanggang 1/2 plus 1 times n. Yeah. So this is equal din kay T of n. So malaking harang sa baba. So ayun, so what's next here is that alam natin dun sa ating recurrence relation na pag n or yung input natin kay T of n is 1, nagiging O of 1 lang siya. So let's set let n over 2 to the k equals what? So because we do this, that means n is equal to 2 to the k and log n is equal to k. Not sure if relevant ko sa dulo, pero so i-substitute lang natin ito dito sa baba. So we get, so medyo umakit baba. So T of n is equal to, let's just use it. Since n is equal to 2 to the k, pwede natin itong i-replace with n. And then dito naman is 2 to the k minus 1. But this is just yung ating n over 2. Tama ba? And then, ay joke lang. If n is equal to 2 to the k, 2 to the k minus 1, this is over. So baliktad. So to the n plus what times n. Then you'll notice naman na lahat naman ng terms dito may mga over n na term dahil dun sa 2 to the k sa baba. So lahat yun may constant na coefficient. And then, although pwede mo rin naman i-simplify yung geometric na series, mas madali yata yun. So since geometric series to, di ba? So from 1 to 1 over 2 to the k. So that is, this is 1 minus 1 2 to the k minus 1 all over 1 minus 1 half. And then this is 2 minus 1 over 2 to the k. Kasi nag-times 2 or to the k minus 2. So since this is just times n, nakuha naman and then pwede natin itong gawing 4 over n. If i-apply natin to 2 to the k minus 2 k over 4. So dyan. And then eventually makuha mo dito is eventually si T of n, yung n over n is yung given O of 1 plus 2n minus 4. So pag ginawa natin yung big O, we get ano yung fastest growing term. So this is constant. So ito lang. So yung linear term lang. So it's O of n. Ayun. So going back dito, this is n. So ayun. Then for this one, dito naman is similar, pero imbes na n over 2 lang is 4 times n over t of n over 4. So for this one, siguro let's try using yung recursion tree method. Balik ko lang yung, yeah. So, hello, co-focus. Yes. So, meron tayong, yung ating recurrence relation is 4 times t of n over 4 plus n. So, sa recursion tree, ang natitira natin per level is yung non-recursive na call, so which is n. So, for the first level, we have n. And then we have 4 recursive calls. 1, 2, 3, 4. And then for each recursive call, n over 4 yung argument or yung nasa loob ng t. So, ito is gagawa ng 4 na n over 4. So, ang difference kung pag ginawa ko to n squared, magiging n over 4 squared, din sila. So, ayun. Pero hindi siya squared. So, ito muna. And then, kada isang level dito is gagawa din siya ng 4 na recursive call. So, nakikita ba yung paano siya nabubuo yung ating tree? And then ito is eventually, dadating siya sa point na magiging 1. So, ito rin, si n over 4 na to is meron din siyang 4 na ganito. So, let's just say, 4 na n over 16. Kasi hindi na kasya. Ito rin, meron ganito. Ito rin, meron ganito. So, 3 lang to. So, pwede yung pansinin per level. So, first level, we have n na total. Sa next level, we have 4 na n over 4. So, that is also n. And then sa next level, we have n over 16. Pero ilan yung n over 16 natin? So meron tayong 4 na n over 16 dito, 4 na n over 16, 4 dito, 4 dito. So 4 na 4 is 16. So this is actually n din yung total. So total. Eventually, kahit anong level na makita natin dito, for example, n over 2 to the k, nakita. Kung meron tayong level na n over 2 to the k, wala naman sabihin. Sulat ko na lang ulit. And ilan yung expected natin na 2 to n over 2 to the k na lilitaw? It's also 2 to the k. So parang meron tayong 2 to the k na n over 2 to the k na terms, which is just n. All the way hanggang sa baba, hindi pala kita. Eventually, magiging 1. And ilan yung terms natin dito? So it will be dependent dun sa ating depth. So, di na pa siya 2. So it's in terms of 4. Powers of 4 pala. So, ito yung mga madaling gawan ng tree kasi parang nagdi-division ka lang. So, for the k, yung sa dulo, ilan yung terms natin. So, dito, sa first level, 1 term, and then 4 terms, and then 16 terms. So, sa kth level, we have 4 to the kth terms. Sa kth level, 4 to the kth terms. Dito sa lowest level is kung ano yung lowest level, tapos times 4 raised doon. So, this is 4 raised to yung ating depth times 1. And then yung depth natin, you can notice here na si n, divide by 4, divide by 16. And then eventually, titigil tayo pag na-divide natin siya by n times. So, ano yung depth natin? Bali, ilang times natin siya i-divide by 4 para makarating dito. So, dapat yung 4 to the d or yung n divided by 4 to the d natin will be equal to 1. So, after 4 to the d na divisions, si n mag-approximate siya kay 1. Kaya tayo makakarating dun sa base case niya over here. O ba yun? Hopefully. Hindi pala ako kita sa video. Now, yun. So, ilang levels natin? So, this is level 0, level K, level D. So, we have D minus 1 levels. Tapos lahat sila N. So, D minus 1 levels times N plus yung last level natin, which is 4D plus 4D. And then, ayun nga, ang ating depth ay equal siya kay pag si n divided by 4 to the depth equal siya kay 1. So, si 4D si 4D, 4 to the D equal kay n, and then log 4, log base 4 of D of n equals D. So, dito, yung nasa loob is log of n minus 1 times n plus si 4D ay n. So, yung ating final answer ay n log n minus n plus n. So, cancel out to. And ito na lang yung natitirang term. So, big O of n log n. So, pag nilagay natin to sa ating will look like n times log n. So, pwede mo i-check yung expression na tinipin mo pag display response. And then this one, parang similar lang siya actually. Dito. Sa recurrence solution natin dito. In this na times 2 per level, nagiging times 4 per level. So, you'd expect here na instead na 2 to the n, it is 4 to the n. And then since yung base case din natin is n, so nakuha natin here is n times n. So, Ayan, so if may konting hindi kayo sure kung bakit yung sagot medyo tanong niyo. Submit all and finish. So yun, grade is 10 out of 10. Yeah. So syempre ako yung gumawa. Mahirap naman kung hindi siya perfect, diba? Formative quiz lang naman to, it's ungraded. Kaya okay lang makita yung sagot. So for the other assessments, medyo kayo na bahala doon. And then, so yun sa time complexity. Although when we talk about yung ating recursive na functions, gumagamit tayo ng extra space. Kasi di ba, gumagamit tayo ng multiple function calls. So pag every time mag-call tayo ng function, napupunta siya or nasa-store siya sa ating program stack. Like so. And ayun, so basically kung ilan yung natawag natin na recursive calls, yun yung ating space complexity. So kailangan nyo lang bilangin. So most probably, it will just be the depth. Although, kung titignan natin, for example, dito kay binary, meron tayong store na na string sa kanya. So lumalaki yung memory consumption niya after every call. And then, nagba-branch out tayo. Pero notice here na pag nakarating naman tayo sa dulo ng isang branch, hindi na lumalampas pa yung memory natin dun sa line na yon. So, ayan, pag pinanood mo yung GIF, parang, ayan, ang kailangan na natin pansinin for our memory is isang path from yung ating main function and pababa doon sa isang dulo niya. So, from binary n minus 1, n minus 2, hanggang binary 0. And then yung space consumption niya nun is bibilangin na natin, like our recursion tree method. So ito is just a constant. Ito is constant plus another plus c para i-store c1. And then this one is constant plus 2c para i-store c11. And then ito is constant plus 3c para i-store c1. And eventually, if we have n terms dito, kailangan natin na n times c2 na memory over here. And then, plus a constant na space para dun sa other variables mo dun sa function. So, ayun lang. Medyo nagtipid kasi sa space dito. Effectively, itong b plus 1 na to is tinostore mo na in a temporary variable before siya mag-call na ibang function. So, well, it depends. Merong iba hindi sa stack memory ilalagay, sa heap memory ilalagay, and minsan hindi yung kino-consider for auxiliary space. Pero ang assumption natin for our discussion is si b plus yung ating string is tinostore sa ating program stack din, which is yung usual case naman. So ayun, when we sum up yung ating terms, it's yung depth times yung number of C1 na terms plus yung summation ni 0C2 hanggang NC2. So this is just a summation ng arithmetic series. So n squared siya in this case. So for other functions, usually, it would help na gawin mo yung ating recursion tree and i-plot out mo yung space consumption per level. And then yun lang naman siya. And then this, sa baba, it's just comparing recursion and iteration. So some recursive functions pwede natin gawin iteratively and pareho yung result. And then, mapapansin din here na pareho sila ng time complexity. Pero si iterative na factorial, hindi gumamit ng additional na space. So yun, effectively, better in terms of space complexity, si factorial na iterative sa hindi recursive. However, parang isipin mo pa, meron ko pang f times I. What if define ko na lang siya straightforward na ganito, tapos na ako. So wala na ako masyadong kailangang isipin. So nasa programmer naman na yun kung gusto niya mabilis matapos or mabilis matapos yung program niya. And then we also have another example, yung sa binary. So medyo mas mahirap siyang i-convert to a equivalent na iterative na function. Meron tayong temporary variable na t na nag-store ng mga intermediate na mga sagot. So usually pag merong yung recursive functions katulad ng binary, wala siyang 1:1 na equivalent na recursion. But if you try to make it an iterative na function, usually magiging mas complicated siya. Kaya depende dun sa type of problem, minsan recursion will make it more efficient. And actually yung pag-compare niya dito is ang ating recursive na binary function only uses n space na n squared na space. Ay, na yung time complexity. So yung time complexity. So meron tayong n squared na space dun sa recursive, pero n2 to the n space for the iterative one. So in this case, because of the recursion, yung program stack, how it's made, nakatipid tayo ng konti sa memory niya. And ayun. So ang main mechanism niya to do that is what we call backtracking. Kasi 'di ba, parang sa binary function, bubuin muna natin yung isang n-digit na number, babawasan after matapos nun, titingnan nyo, bubuin muna yung isang 3-digit na number, and pag nagawa mo na yung 3-digit na number, magba-backtrack ka or parang i-undo mo yung huli mong nilagay, and iba naman yung lalagay mo. So in that case, parang nakakatipid tayo ng konti sa time. So hindi natin kailangan gumawa ng n-digit number every time. Pwede tayong mag-start sa n-digit number, bawasan ng isa, and we have a new n-digit number pag dinagdagan natin ng bago. So yun yung sa backtracking. And it can be applied to other things as well. So yun, ang summary lang, yung ating time complexity or recurrence relation din ng ating recursive functions, siya yung nagde-determine or yung ginagamit natin to get yung kanyang time complexity. So yung general form niya is medyo generic. So yung una is yung recursive calls natin. It can vary kung ano yung function natin sa loob. So for in this case, yung ating factorial is just n-1, and then yung for the binary is dalawang n-1. So dalawang functions yun. And then naka-add lang together. And then ayun, plus a time dito for the non-recursive na calls dun sa ating function. Then we have two methods to simplify yung recurrence relation para makuha time complexity. And ayun. And then we have one exercise for week 3 na hopefully ma-extend yung mga given na algorithms para makuha siya. Then actually, since recursion yung topic for the week, required na recursion yung or recursive yung solution nyo for week 3. So I think we can look at yung sa week 3 na exercise. So ayun, essentially ang gusto lang mangyari dito is mabilang nyo lahat ng same total na hexadecimal number doon sa tag na binigay doon sa item. So for example, yung tag nakalagay is 8F. Meron tayong 7 hexadecimal numbers with the same total. So yung price niya is 7 pesos. And basically yun, for any other input, kailangan nyo lang i-count lahat ng hexadecimal numbers na same total. So I guess meron tong iterative na solution. But syempre gusto natin ma-practice yung recursive skills natin. So, siguro ang hint ko na lang, meron tayo dito that prints all binary, or I guess pinupuntahan niya lahat ng binary numbers na n digits. So, siguro madali lang naman from there makuha yung siguro from binary, paano kaya to i-convert to hexadecimal para makuha natin lahat ng hexadecimal numbers. And then tingnan na lang natin kung alin doon yung may same na total. So that is one way to solve yung ating exercise recursively. And ayun, any questions for week 3? I guess I can move on to a preview ng ating week 4. Well, medyo mabilis lang ako dito. Kasi puro examples lang naman yung ating code. So for week 4, ang focus is divide and conquer, which is a programming or problem-solving paradigm. Din naman siya in general, hindi lang siya for programming. So ang concept ng divide and conquer is yung ating big problem is i-divide natin into sub-problems. And then yung sub-problems, pwede pa natin i-divide. And then pag yung problem natin is maliit enough, madali na lang siya i-solve. And mako-conquer na natin siya. And then pag na-conquer na natin yung ating mga maliliit na problems, pwede natin i-combine yung solution nila to solve our bigger sub-problems and eventually ma-solve yung biggest problem as a whole. So ayun, medyo straightforward lang naman siya. So it's just a way of how to solve yung ating problem. So ang example natin dito is searching. So given a list of numbers, hanapin mo yung index ng isang number. So ano yung index? 6769. So index number 4. So pwede mo namang isa-isahin yung elements ng list. And pag meron nag-equal, yun na yung nahanap mo na siya and alam mo yung index niya. Although, ayun, since yung ating list ay sorted, we can use what we call binary search. So for binary search, pwede nating hatiin yung ating list. Since alam natin na sorted yung ating list, pwede natin tignan yung middle element. And if yung middle element natin is mas maliit doon sa hinahanap natin, ang kailangan na lang natin i-search is itong part na to. So, essentially, ang nangyari ay, ito yung buong list natin. And then, tinignan natin sa gitna kung ano yung kailangan pa natin check. So, since alam natin sorted, kung sinesearch natin is 9932, o compare natin dito, mas malaki siya kay 8184. So, pwede na natin i-disregard lahat ng nasa left niya. So, na-divide natin yung list by half. So, ito is conquered na. Hindi na natin siya kailangan hanapan pa. So, ito na lang yung kailangan natin pansinin. So, paano naman natin siya isa-search dito? Pwede natin apply yung same principle. So, titingnan ko yung middle element. Mas maliit siya. So, pwede kong tanggalin lahat na nasa kaliwa. And then, ito na lang yung kailangan kong search. So, nahati every time yung ating input. And paano nagagamit yung recursion dito? So, paano mo isosolve yung, or paano mo i-apply yung binary search pagka, so, pagka ito yung list. So, parang applying binary search for a list this long, you compare yung middle element, and then determine kung alin yung partition. So, alam mo na yung partition na kailangan mo pansinin, which is this one. So, paano mo siya hanapin dyan? You use binary search. Search. So, ayun, ang divide and conquer usually used with recursion, although hindi naman siya necessary. So, kung ano here, titignan mo, Si index of is yung binary search. So binary search from 0 to n. Ang call niya is binary search from either middle to the end or start to the middle, depende din sa value ni key. So hindi mo na siya kailangan masyado isipin. Paano ko hahanapin yung element dun sa right subarray kung alam ko na nandun siya? Parang i-apply mo lang din yung same na algorithm basically. So yung time complexity niya, since recursive siya, we start with the reconciliation. So we call yung t. So for originally n elements, and then sa next call is n over 2 elements plus a constant time for the other stuff. So ito, ayan. So, supposedly medyo alam nyo na dapat paano nag-work to. And eventually makukuha mo na time complexity natin is linear, ay logarithmic time, which is better than yung original. Then for the auxiliary space, so we have yung depth natin na log n. So we have logarithmic din na space. So it uses more space. So which one is better? Depende if meron kang additional space or meron kang additional time. And another option is baka yung ating recursive na binary search, pwede natin i-convert to an iterative na binary search. So wala na yung problem altogether. So yung next example is merge sort. Siguro ito yung mas ma-apply or mas ma-appreciate natin yung paggamit ng recursion for divide and conquer. So for merge sort kasi, we start with a list. And then ang unang gagawin is make partitions. So basically meron tayong actually isang partition for each element pala siya. So, we can start here. So kung meron kang dalawang partition na sorted, i-merge mo lang sila by choosing yung smallest element sa kanila. Pero for example, meron akong dalawang partition na ganyan, yung isa hindi pa sorted, paano ko i-sort yung isang partition? So para i-sort yung isang partition, i-apply ko si merge sort. So i-merge sort ko muna yung mga partition. And then if sorted na yung buong partition, mas madali ko na lang siya lang i-merge. So ayan, so nakukuha yung recursive step or recursive na call. So si merge sort is so meron ng merge sort na helper function which calls yung recursive na merge sort. So yung recursive na merge sort is just i-merge sort ko yung left side, i-merge sort ko yung right side, and then i-merge ko sila. And then we now have yung ating sorted na list. So yung kulang, yung I guess yung step na lang na kulang dito is yung pag-merge. So since dalawang sorted na list naman na yan, mas madali lang sila i-merge. Kailangan mo lang hanapin yung smallest element dun sa dalawa, which is nasa simula dapat. And ayun, madali lang piliin kung ano yung next element na kailangan i-add doon sa resulting na list. So ayun, ang merge sort is or calls to other copies of itself. So yung ating recurrent isolation is 2 times t of n over 2. So yung merge sort ng n elements is dalawang merge sort ng n over 2 elements plus yung running time ng pag-merge. So yung running time ng pag-merge is may n elements tayong kailangan ilagay sa or meron tayong dalawang n over 2 na elements na kailangan combine to a single list. So that takes linear time. So mas simplify mo siya to 2 times t of n over 2 plus n plus a constant. So actually by this point, pwede mo nang i-eliminate yung constant kasi magiging negligible naman siya if n is sufficiently large. And ayun, parang similar dun sa ginawa natin kanina na version 3. kahit na hati by 2 yung ating n, dalawa naman yung nagsispawn. So, dalawa yung nagsispawn. Or dalawa naman siya per level. So, yung total na term or total na number per level is constant siya na merong n and then plus some constant na lumalaki. And eventually, ito yung makukuha expression per level is n plus 2 to the k plus 2 to the k times c1. And si k yung depth natin. So yung ating depth ay log n. And eventually, makukuha mo na yung summation natin ng lahat ng p of n dito is 2 to the depth times c2, yung last level, and then summation ng n plus 2 to the k, which eventually leads to n log n. So n log linear, or log linear time na tinatawag n log n, which is definitely better yung ating O of n squared. So, at paano naman yung space complexity natin dito? So, since meron tayong additional function na merge, kailangan natin i-account din yung memory na ginagamit ng merge. Pero pwede natin ihiwalay yung memory na ginagamit for recursion. So, for recursion, going back dun sa ating implementation, meron tayong dalawang temporary na list dito na left and right na both would have n over 2 elements. So, for each function call, si merge shortly n, kailangan ko ng dalawang n over 2 na arrays. And then for merge sort n over 2, kailangan ko ng dalawang n over 4, and then dalawang n over 8, and then dalawang n over 16, etc. and etc. So yung total na memory na kailangan ko from merge sort n to merge 1 is yung itong summation na to. So 2 times n over 2 to the k minus 1, or eventually 2 minus 1 over 2 to the k times yung sum ng C1. So, ayun, some would argue na kailangan lang natin yung depth. But in this case, since gumagamit tayo ng extra space, since meron tayong left and right over here, kailangan natin siyang i-account for. So, meron mga implementations ng merge sort na hindi kailangan gumamit ng temporary na lists like this. But for our example, I guess to just stick to what we have, ang ating memory or space complexity for the recursive step is itong term na to. So, actually, linear term siya. Titignan niyo pa lang dito. And then, kailangan din natin ng additional space for merge. Looking back sa ating merge function, meron tayong temporary list here, and mapupuno siya with the elements of A and the elements of B. So, eventually, that is n elements. So, kailangan natin ng up to n memory space. So, ayan. So, O of n to merge, and then si recursion itself is log n plus 2n. So, eventually, may linear memory space na kailangan for the merge sort. So, merong mga other implementations na kayang mas konting memory. But for our current example, it's O of n. So, yun. Comparing lang, yung ating n-squared sorting algorithms, they run in n squared nga na time. Pero lahat naman sila ay constant yung kanilang space complexity. So, for merge sort, gumamit tayo ng konting space, linear space, of n na space, to reach a much faster na log linear na time. So, to compare lang siguro kung gaano siya kabilis pa, if for example, I have n equals 100 or 1024 para madaling i-logarithmic. Pag n squared, this is around, approximate ko na lang, 1 million. But for n log n, this is just 10 times than 24. So this is approximately 10,240. So compare mo naman si 1 million kay 10,000. So mas malaki or mas mabilis talaga si n log n. So kung gusto mo man if gagamitin mo man si merge sort, it is definitely worth yung extra space natin na O of n. Although, ayun, hindi naman totoo. Baka meron kang computer, medyo gipit ka sa memory, kaya mo naman maghintay. So, it might not be the option for you. And then, our last example for divide and conquer is yung maximum sub-array na problem. So, basically, gusto natin makuha yung highest sum ng consecutive na numbers sa isang list. So for example, ito yung list natin. Naka-plot out na lang para mas madaling i-visualize. So pag tinotal ko from this point hanggang this point, we get a sum of 43. And no matter what combination or anong consecutive pa na list yung kunin natin, walang lalaki pa sa 43. So yung straightforward na approach, yung n-squared na approach is just check every possibility ng start and finish ng ating sub-array and then store lang kung alin yung maximum. So I less than length, j less than length. So si j yung ending, si I yung starting. So lahat ng possible starting, lahat ng possible ending. And eventually makukuha mo rin naman dapat yung tamang sagot. Pero yung running time nito is sabi nga naman yung section is O of n squared. So if you want to use a divide and conquer approach, we can divide our list. So we can look for the maximum sub-array na nandito sa left, maximum sub-array na nandito sa right. So dalawang possible places na makita yung maximum sub-array. Ang third and last possible location ng maximum sub-array is yung nandito siya sa gitna. So kasama yung middle element. Kasi isipin mo, kailangan kasama yung dalawang middle elements over here. So if hindi kasama yung middle element over here, makukuha dapat natin yung maximum sub-array pagka kinuha natin yung dito sa right. So eventually, makukuha mo dapat if wala siya dito sa baba, if wala siya dito sa taas, nandito dapat siya sa gitna. And to look for the maximum sub-array sa gitna is mas madali siya. Kasi alam mo na kasama yung element na to, pwede tayong mag-extend lang na mag-extend dito hanggang makuha yung maximum sum. So, dito kasi, dun sa original na n-squared na approach, hindi mo alam saan mag-start, saan mag-end. So, lahat ng possible start, lahat ng possible end, kailangan check. Pero here, pag meron tayong condition na kailangan kasama yung element na to, alam na natin yung ending, so kailangan na lang dalawin yung starting. And vice versa, pag nahanap na natin yung maximum sub-array na tumatama dito, i-extend na lang natin siya sa kanan. So yun yung ginagawa dito. So ito yung meron ng mga debug statements to help you. So parang meron tayong tatlong contenders for the maximum sub-array. So the first contender is yung maximum sub-array from the low hanggang sa middle. And then the other contender is from the middle hanggang high. And then yung third contender natin is the one that crosses yung ating yung ating midpoint. So yung ating maximum sub-array crossing. So yun, starting from the middle, extend to the left, hanapin yung maximum, extend to the right, hanapin yung maximum. And then ngayon, compare lang kung sino yung pinakamalaki and yun yung i-return. Return C-max. Tapos meron lang tayong mga base case dito. Siyempre, pag isang element lang yung array, isa lang yung possible na sagot. So, pag single element, yung maximum sub-array lang na, isang element, kung sino man yung low or high, depende dun sa gusto. Pareho lang naman kasi high minus low plus 1. And ayun, complexity analysis niya, medyo the same. So meron tayong dalawang, para siyang merge sort, meron tayong dalawang recursive call, and then meron tayong isang extra function. So yung complexity niya is 2 times t of n over 2 plus yung time complexity ng crossing. Yung pag-cross natin is mag-extend sa left and then mag-extend sa right. So that is just linear. So medyo binibilisan ko lang. But hopefully you get the point or you get the gist of how that is gotten. And then for the space complexity, so yung crossing natin na subarray, hindi siya gumagamit ng extra list. So puro single variables. And ito rin, walang ginagamit na lists. So yung ating time or space complexity is just yung ating depth or recursion depth, which is log of n. And then, ayun, which one is better? Ayun, so for divide and conquer, parang similar sa merge sort, mas mabilis tayo, except that we use more memory. Then, ayun, if you recall sa divide and conquer, lagi naman tayo nagde-divide. So, most often than not, yung ating recurrentialization would look something like this. So, a times t of n over b plus f of n. So, a yung number of partitions na kina-conquer, b yung number of partitions na ginagawa, and then f of n yung time natin to merge or yung mga crossing na or to combine yung ating mga solutions. So given this form, pwede natin makuha yung ating time complexity without actually going through yung recurrence tree or yung substitution. So, ayun, so si f of n daw, if mas maliit siya than n to the log b of a, then yung time complexity natin is n to the log b of a. So, another note lang din, yung theta notation, this just means na yung upper bound and yung lower bound is the same for our function. So, yung ating theta notation, theta of n, ibig sabihin lang nito is that yung big O of n natin, or yung worst case, tsaka yung omega of n natin, or yung best case, ay equal. So, kaya siya theta. So, no matter yung input, we usually get the same time complexity. Then, ayun nga, pwede mo itong i-apply sa ating nakaraang functions. So, yung binary search natin, f of n is equal to 1, and then we have two partitions, but only one partition is explored, basically. So, n to the log b of a is ang kanyang log to the b of a is equal to 1. So, comparing 1 to f of n. So, si f of n ay 1. Si n log b of a is also 1. So, we have yung ating second case over here, wherein ang ating time complexity is yung n log term plus log of n. So, log of n eventually. And pwede mo rin itong i-apply dun sa ating other functions. Then actually, if you recall, yung ating mga ibang example for week 3, pwede nating balikan. Ibalik natin para ano. So this one, for the first example, we actually have a same form. Wherein yung A natin equals 1, yung B natin equals 2, and then ang f of n is equal to n. So, i-compare natin si n to the log base 2 of 1, which is equal to n to the 0 or 1. And then we compare 1 and f of n. And mas malaki si f of n. So pag mas malaki si f of n, our answer follows yung form ng f of n. Or kung ano man yung big O or yung theta ni f of n, yun na rin yung ating function dito. So this is just n. So recall may sagot naman natin kanina, n din naman. So mas mabilis siya, di ba? So hindi mo na kailangan mag-imagine. And then for the next one, we have A is equal to 4, B is also equal to 4, and then f of n equals n. So yung log base 4 of 4 is equal to 1. So yung n to the log, mahaba kasi sulat, lagi ko naman. N to the log is just n to the 1. And comparing it with f of n, we say we get na equal sila. So yung ating sagot dito is yung n log n. So same answer din sa kanila. So, ayun, if nag-a-advance kayo, gusto nyo sagutan to, merong mas madaling way, basically. So actually, there are total of 3 ways to simplify yung recurrence relation, and yung substitution, recursion tree, and yung master theorem. However, yung master theorem, applicable lang siya pag ganito yung form ng ating function. And it also needs or requires na yung ating base case ay constant yung running time. So kailangan yung base case is always constant to apply yung ating master theorem. So ayun, that's all for the 2 weeks. Diba? Ikli lang, kaya in 1.5 hours. For assessments pala no week 4, we have meron tayong examples. For assessments, we have a summative quiz and a coding exercise. Yung summative quiz, unlimited attempts, but mostly essay. So, yung sagot sa essay part, hindi na check agad unless kailang or gusto nyo i-request na i-check namin agad yung sagot nyo doon sa essay part ng ating quiz. Kasi, if you recall, yung aming mga activities ay nakasplit into isang easy 40 points, medium 40 points, tsaka hard na 20 points. So yung hard na 20 points, nakapasok siya sa summative quiz. Then for the hacker rank exercise, and so basically meron ng konting kwento. Pero ito yung gist lang naman na kailangan siya makita. So find the sequence of consecutive rows where yung difference nung sum ng odd numbered rows at saka nung sum ng even numbered rows ay maximum. So when you hear the word consecutive and yung maximum, I hope that suggests kung ano yung kailangan yung gawin. Then, after nyo makuha yung maximum na consecutive rows, kunin nyo yung first number ng first row, second number or second element ng second row, yung consistent. And then so on until makakuha tayo ng sequence. And yun yung kailangan yung output. So for example, sample input natin 1 is ayun, 5 rows, 10, 23, 16, 25, 12, etc. etc. So yung consecutive rows na maximum yung difference ng even numbered sa odd numbered. So pag kinuha mo yung sum nito plus yung sum nito and then minus yung sum dito, yung difference ay maximum. Okay. So, pwede mo rin i-add mo yun dito, add mo yun dito, itong dalawa, and then you compare. Kung yung difference ay mas malaki, edi isali mo siya. If hindi, hindi mo siya isasali. Pero if sinama mo rin to, and then sinama mo pa to, add mo rin to. So, yung sum nitong tatlo, subtract or kunin mo yung difference niya with the sum nitong dalawa. Pag mas malaki, yun yung kukunin. So, ayun, highlighted yung consecutive rows na maximum yung difference. So, kunin mo yung first element dito, second element dito, third element dito, and yun yung expected na output. Then, may other sample input dito. Mas malaki. So, 10 digits per row. Ayun pala, yung input natin, ang first one is yung number of rows and columns. And then, yung rows and columns na after. So, we have, excuse me. Ayun, so, makuha mo dito yung merong maximum difference between odd numbered and even numbered rows ay itong tatlong to. So, actually, yun, wala nang iba pang consecutive rows na meron pang mas malaking difference ng totals. So, ayun, 29, 9. Then, may option kayo na mag C++ or mag Python. So, medyo kayo naman bahala. But, ayun. So, umabot tayo na medyo 1 hour and a half. Anything from questions, clarifications? Wala ba? Tulog na ba kayo lahat? Hello? I guess kung wala na kayong iba pang katanungan or gusto clarify, we can end here. And last chance to ask anything para masagot ko kaagad. Otherwise, ayun, you always contact me to Discord or email. And apparently pala yung mga iba hindi gumagamit ng EEE na email. So, ayun. Well, siguro, tip ko lang, eventually, kakailanganin yung gamitin ng EEE email nyo. Kasi lahat ng halos yung mga materials sa EEE subjects, kailangan yung EEE email to access yung materials. Kasi pag naglalagay kami sa drive ng EEE, kailangan minsan EEE din yung account na gamit nyo. Just to make sure na hindi lumalabas ng institute no? Data. Pero, ayun. If meron pa kayong mga classmates na alam nyo na doon sa same section pero wala sa Discord or hindi alam na nag-email ako, pakisabihan na lang sila. Yun sa mga, yung mga hindi pa na nag-check ng triple email, medyo kayo, I would like to ask for, I am sorry for assuming, or I guess, oversight ko lang na hindi nag-check ng ibang emails or nag-send sa ibang emails. But either way, week 3, week 4, medyo pabelo pa rin naman tayo to the course. So, at least na-add na or na-resolve na yun. And ayun, if there are no more questions, you are free to go. Thank you very much for your time.
Thank you, sir.